Welcome to week 3. So, in week 3, we shall look at data cleaning. We are going to clean our data and prepare our data for our AI machine models, right? So, we're just preparing that data in this lecture. We're going to take things that we learned in week 2 and we're going to apply those here. So, it's just a revision of that as well as adding some new information to what we already have. So, just going to have a quick look at our roadmap again, then we get into it. So for our roadmap, the first thing we have to do is define the problem, right? What do you want to solve? And you have to look at the scope of it as well. That's the first thing you do. You don't just get up and say, let's build a AI model. What do you want the AI model to do? What type of problem is it solving? So that you can pick the right model, right? Or you have the right model or possible models in mind. And then after that, you look at data handling. So data handling, this is where we're now performing all these for all these different things on our data set to make it clean and ready for those processes. So we're just trying to make sure that our data set is complete, it's correct, it's what you want. You also want to understand the data during this process. So what we're doing in week 2 and what we're doing in week 3 is going to be the processes you will have to repeat when you're doing data cleaning for any AI model that you might want to use, right? Then after that process, we're going to look at model selection. So now, you're now going to have to actually choose the model and set up and do the setup. So you're now coding so that the model works, right? And then we look at, after that, we have selected our model. We'll look at training and optimization. So we're training our model and we're optimizing it so that we get the best results. Then how do we know we have the best results? We look at evaluating that model. Then after that evaluation, and if our model hasn't passed maybe the standards that we want, or we just want to keep trying, we circle around that training and evaluation. So we go back and forth there until we have what we want. Then after that, we move on to deployment. So now we're saying we now have a model, we can now push it to our different applications, websites, or wherever we might want it to work. So this is what we have. So now let me just move back to what we might be looking at in this week's session. So sorry. Oh, my runtime has been disabled. All right, that's fine. I'm just trying to scroll over here. Right, that's fine. So this is what we did last week for week 2, right? So today we're looking at week 3. So some of the stuff is non-new, like I mentioned. So don't worry about that. So the first thing we do, so for week 3, you can look in the ebook. We're using Machine Performance 2. This is what we have, and it's mounted in my drive. So over here, I import pandas. So pandas helps us work with structured data, right? And we want to display the first 5 rows so that we just understand what we have. Okay, so we have the machine ID, the runtime hours, temperature. We have also another temperature. We have a vibration level, power consumption, maintenance, and fault counts, right? That's what we have over there. Another way we can quickly learn how many columns we have and rows we have is using data.shape over here. So data.shape helps us with that. Just a quick way to check how your data looks. So shape gives us 1002,8. So we have 1002 rows and 8 columns. This is what we are getting from this. This is what it tells us, right? So that's fine. Then we can just check data.info. Again, data.info tells us that we have formation ID. We have non-now numbers, this such, and then this is a float, this is an object, this is an int, this is an object. Then we can see that here we have 999, so forth. So that's that. You can also use data.describe. Like what we learned, you can apply those as well, just so that you refresh your memory there. So there's something that we just noticed right over here, that we don't have 1002 entries for all the columns that we stated here. That means we have, some missing values that are needed. And like I said, for our machine learning model to learn well, the data that we feed into it has to be complete. We need complete data there. So we can check how many missing values we have. We can count over here. It's quite simple. We know that it's 3. So we can use is now dot sum. So on our data we can apply is now. Is now checks for missing values, right? And then sum would then count how many are in each column. This is what we're getting there. So let's run that. Oh, sorry, I'm having a hard time scrolling. So over there, we're being told that we have 3 in temperature C and 3 in power consumption over there. So these are the values these are the missing values that we have. So in other cases, it may not be this simple. I just made sure that we had a few missing values, since this is how we're introducing them, so that we wouldn't get a lot of confusion. But you might find that you might have a lot, maybe 100, 1000 missing values, just depending on how big your data set is and how many problems the data in collection process incurred, right? So that's what we have. But we have to fix that. We don't want to have missing values, right? That's something that we have to think about. We don't want to have missing values. So just think about that as well. Then another thing that we might have in our data set might be duplicate rows, whereby we have a machine ID, maybe machine 01. It has multiple entries, right? We don't want that in our data set. Our machine learning model won't end well. You can also go and get and research about it, why duplicate rows affect how they affect our model, and you can also look at how missing values affect our models as well. I'll ask that during one of the lessons, right? Then we also check for duplicate rows, like I mentioned, and again we apply data to our data, apply duplicated. Then this one returns true if a row is repeated, right? But we want to count how many of those rows are repeated, so we have some to do that for us. So when we run that, we have NP N6 true. So those are true values that we have. Let me just try to do something here so that we can, let me remove some. It's just that the lucky part is that the duplicate one, I put it at the end. So it's going to be very easy to notice over there. So I put it at 1000 and 1001 in this position. This is where we have them. So you see how they returned true. This one means this one is a duplicate of, then this one's a duplicate. So that's just the same machine that I ended twice over here. So it's telling us that we have a duplicate row there. So it's the same thing that we have there that we have here. So this is what it's showing us. So let me just put back the sum. Okay, I meant over there, right? Then now our options for our missing values, the ones that I mentioned this. So we now want to fix this thing is that we have. How do we fix them? How do we fill in the values that are missing, right? So the first option is you can just drop those. Let's say there are a few values. You can say that, for this scenario that I have, it's not continuous. Maybe it's not continuous data. You might say, I could risk, just letting go of these few entries. That's one way of doing that. And you can use this one called data drop NA. This one removes rows that contain missing values. You can use that one. So you create a new variable over here. This is the variable that we have. This is what's going to be storing our data set now. Then the data that is stored in cleaned data is data that doesn't have the missing values. Or you can fill in those missing values with something else. You might say, all right, for the values that for the columns that have rows with missing values, we can fill in with maybe an average of that column, right? We can do that. So you can do that. So for over here, we saw that temperature had some missing. Let's just go back there. All right, let me just scroll. Missing values over there. Temperature had 3 and power consumption had 3. So I'm just going to show you with temperature. You can say now data temperature C. So we're touching on the temperature column over there. What you do to that column? So this is the new column, right? Then what that column is going to fill na over here, fill NA is going to fill, or rather it's going to replace those missing values with the mean of that entire column, right? So mean over here, it will calculate the average of that column. So data temperature is that column, we calculate the mean, and then that mean, that value that you have, let's say it's 20, the field NA is going to come in and replace all the missing values that is sees in temperature C with that 20. So that is what's going to happen here. So this is what we have. So we now know that. So our data temperature column is now going to have let's just run that. It's just going to have this code there. So what we can now do after running that, we can now come in and say, we can now come in and check data is now sum over there, right? So we can say data dot is now. So dot sum over there. Then let's run that and see what we get over there. So we see the temperature, we no longer have, temperature, we no longer have those 3 missing values. So you can do that for power consumption as well to fix that. Then we can also rename a column. You can rename a column by using data.rename. Then you have your old name there and you have your new name. So in place, when we set this to true, it means we are modifying the original data set, right? So this is what it means. So we are modifying the original data set. So it now has this. We're not doing it like what we did over there where we're setting it into a new variable with a different name. So this one is actually changing the original data set that we have. We can also create, you can run that. And then you can also show the data there. You can create a new column there. Let's say a new column, and then you perform calculations using old columns. Unfortunately, this data set didn't have efficiency. So you can try it out with a different column that you might want to create. Then you perform a calculation. But let's say it did have efficiency, the one we were dealing with last week. People would come in and want it in percentage. We would come in and say data efficiency, and we multiply that by 100. Since the previous efficiency that we had in our previous data set was a float value, right? It was like 0.1, 0.2. No, that it was less than 1. So from 0 to 1, you could multiply that by 100 to get the percentage, right? You could do that. So left side is the new column name, right side is the calculation. We can also sort our machines. We did this last time. We can filter. We can get summary statistics. That's fine. We can also use group by. So with group by, this is a bit new. So group by splits data set into groups. For example, over here, we have data group by maintenance flag, by run hours, and then we have the dot min day. So run hours over here, we are selecting the column that we want. This one is the run hours, right? So let's say we are told to group data by maintenance flag and calculate average run hours. So we are grouping it by the maintenance flags. So it says that we have a yes and a no. So for the yes side, you want to calculate the average run hours, and for the yes side, for the no side, you want to calculate the average run hours as well. So group by, right, we'll group our data set. For this example, we'll group our data set by the maintenance flag. So for maintenance flag, we either have yes or no, right? So it will calculate the average run hours for the group, for the yes group, then for the no group. So this is the syntax. So you use group by, we're grouping by the maintenance flag, we put that in the parentheses, and then we select the column that we want to make the calculations on. Then over here it's run hours, we select that column, and then we use dot mean to calculate the average within each group. So this is what we have over here with group by. So this is what we can get group by with group by, sorry. So no, this is the average run hours for the no group, and then for the yes group, these are the average run hours that we have. So you can do that again. Let's say you're asked to calculate average vibration levels grouped by maintenance. Again, in parentheses, this is how we are grouping them. Then this is the column where we are making our calculations, the average of vibration levels there. So you find that these questions are asked in the ebook. So this is how we can work them out. Then an alternative method. So if you don't want to use the group by and you want to use our filters, the ones that we learned last week, you can use that as an alternative method. So average run hours only for machines needing maintenance. So you can use a filter for maintenance flag there. We use data.maintenance flag, the ones that are equal to yes, and then you select the run hours and then you get the mean. Then if you want to now do for the no group, over here come and replace the yes with a no. So we can also count machines by maintenance status, right? Let's say you have data dot group by, and then you group by the maintenance flag, and then you can get the size of each group. So over here, if we run this, we can get no is 710, then yes is 292. This is how you can also get a count from that. We can also apply functions. This is how we're doing it last time, using the apply last week. So you can watch the last week's video and get up to date there. Then conditional filtering, the same thing. Each condition was in its own parenthesis, and then the end, we put that there, meaning and, like in where both have to be equal to, like, true, have to be true for it to pass. Then again, we're going to be using lock. Lock and iLock were introduced last week. So for lock, it's local, it's label-based indexing. Right over here, where we have the 0 representing the row label, and then this one, the run hours, being the column label. Then we're going to have iLock, which is position-based indexing. So with iLock, we have the first value representing the row position, and then the second value representing the column position. So you can play around with this and figure out which values you get over there and what they represent. So these are the run hours there, the column label. So it's for a specific machine, the first machine there. Then over here, the row, the first row. Then this one will be the second column. Then these are the values that we had. So I think that's all for week 3.